So today's the first lesson on computing numbers, especially fractions. Okay, when we talk about numbers, we do not always mean integers. Okay, integers are numbers, but numbers could be more general. Okay, could be rational numbers, could be integers, could be natural numbers, could be whole numbers, right? Or could be irrational numbers. What is irrational numbers? If they are not rational numbers, very simple. So irrational numbers can be written in this form. But if it's expressed in terms of a decimal, then irrational numbers can be expressed as numbers with terminating or repeating decimals. Okay, so for example, 23.87. Okay, this is a rational number, right? And it's terminating decimals 7. Okay, it can be also like a 5.2345, 2354, 2354, and repeating. And this number is written 52354. Put a bar on that because those 4 digits are repeating. And this is also rational numbers. But you already said that the rational numbers by definition are fractions. So can we convert a rational number into a fraction? The answer is yes. For example, 23.87 is going to be 23 plus 87 over 100, right? Therefore, you get a fraction. And this will be like a 2300 divided by 100 plus 87, 100, right? So finally, you will get a fraction. Maybe you can simplify, maybe not. So this is a fraction. So indeed, this is by definition is a rational number. But how about the one? Like 2354? Put the bar there. Well, we have a general formula. If 5.2 bar, right? So that means that will be 5 plus 2 over 9, right? Right? 5 plus 2 over 9. So you get 47 over 9. Right. If 5.23, put a bar here, right? That'll be 5.2399. Right. 5.3, hold on, yeah, for 99, yeah. Right. Then you can combine them, right? 5 plus, right? So, and then you combine into one fraction. How do you do that, right? How do you add the two together, right? 5 times 99 plus 23. So that'll be 518 over 99. And maybe you can simplify a little bit, but that is going to be the fraction. Okay. So repeatedly, just so you can convert them. Right. Well, especially 0.3 bar is going to be 1 over 3. Right. 0.3 bar is going to be 3 over 9, but after simplifying, it's 1 over 3. Okay. Now, the most important in this case is 0.9 bar. 0.9 bar is 0.99999, but that's going to be 9 over 9, which is going to be 1. Right, this is going to be 1. Irrational numbers those are the numbers not rational. Okay, how many of them there are? There are more irrational numbers than rational numbers. How many rational numbers there are? Infinite many, but how can you say more than infinite many, right? That's an interesting question. So between 0 and 1, how many rational numbers there are? Okay, so between 0 and 1, there are infinitely many rational numbers. Right? Yeah, I'm going to post. I always post the lecture notes to you. Okay, I will send it to you by email as long as your name you register. Don't change your own email. Okay. Next time when you get on, I hope you use a link already sent it to you when you register. Use that link to get on internet. Otherwise, every time you have to enter the meeting number and then maybe later on you have to use password. Then you have to use your name. Some students choose their names. You know, your original name may be called Lala Wu, right? But then you change your different names and nobody can recognize it. At least you should keep the same names. And then you also, maybe you also ask to enter email address. That must be same email address your parents register for you. It's their email address because I'm going to send lecture notes to them directly. If they want to, you get the same copy, they just ask me, send me your own email address associated with your parents' email address. So both of you will send, you will get the email address, okay? And both of you will get my lectures. Okay, I will not post the video always, okay? And I try to record every lecture. Sometimes like technical reason, maybe I couldn't convert the file. That happens once. So I cannot keep the promise, okay? But 99% chance I have the recorded lectures. If you miss the class for some other reason, okay, then once you get my homework and lecture notes, just reply to me, hey, I missed the class, and I don't understand the material. Can I have the video? And you probably have to wait for 1 day sometimes. After I convert it, post it, then I'll send you the link. All right, clear? Good. All right. So there are infinitely many rational numbers, okay? And but in mathematics, we call them countable. Okay, you can count 1 by 2, the infinite many, but you can count 1, 2, 3, 4, 5, 6. This is the first rational number, second rational. But the irrational numbers, they are more than infinite many. What do you mean more than infinite many? They're actually uncountable. Okay, just all the irrational numbers, uncountable. Okay, so think about our universe, right? If how many stars there are, even the infinite many stars there, probably you can count them. So we have a countable stars there, okay? But maybe we have infinite many atoms. We cannot count them. That's a possibility. Okay, uncountable. It's just too many. Okay, but we don't know. We cannot prove it right now. Okay, so let's move on. But mathematics is very special here. We assume when you draw a point, but when it's asked how big of the point, there's no dimension. Okay, point is just a point, 0 dimension. Okay, and when I draw a straight line, how many points on this line? Infinite many points. Yeah. All right. So let's try and do the first problem. 0. Add those two numbers together and express as a fraction. Well, when you do this, right, you firstly convert it to a fraction. The second one is 21 over 99, right? And 99 is 9 times 11, right? So 99 is 9 times 11. So I can get 5 times 11, 9 times 11. Here's 9 times 11, 21. So add them together. 55 plus 55, right? Plus 21, right? And that will be 76. And then over 99. Okay, so that is a fraction. That is a fraction. Now, I was wondering, so sometimes, yeah, we only consider those kind of reciprocal of an integer, okay? Reciprocal of the integer. reciprocal of an integer. This is a positive integer, okay? And we want to know when it has terminated decimal, if we express it, okay? When it has terminated decimals, okay? If this can be expressed as a number, okay, with terminating decimal, we find out, okay, we find out this one has a terminate decimal if and only if n is either divisible by p or divided by 2 or divided by q. Okay, no other choice. So that means if I divide 1 divided by 3, I get 0.3333 and repeating decimals. Okay, repeating decimals. And then if I divide by 6, you get 1 over 6 the same because 6 is not a 2, not a 5. Okay, you can try 1 divided by 6 and you get 0.16666 is repeating, right? Repeating 6. Okay, then how about 1 over 23? And the same, it's the same thing. 0.04347. Okay, 434782608695. Now it looks like, okay, so this is a trick here. So is there any, can you see any repeating decimals? Well, that's really bad, okay? My calculator is not good enough to show you, okay? The digits, as there's a set of digits will be repeating, right? It will be repeating. So at this moment, you don't see it's repeating, right? But if you write down more, it's repeating, okay? It's guaranteed. All right. Now, only when the integer contains a factor 2 and 5, then it has a terminating decimal. Okay, it has terminating decimal if only if n can have this factorization 2 to the p, 5 to the q. 2 to the p, 5 to the q. Okay. Yeah, and so let's try a number 50, right? 1 over 50, okay? 1 divided by 50, and then 0.02, right? It's not bad, right? And then let's try another number. 8 times 25, right? It's 200. Well, that's also good, But let's try a different one. 4 times. Yeah, it's really not a good example. Anyway, so if you want to get the terminating decimal, and this n must be divided by 2 and 5, right? Now, we already learned the notation called the square root, right? A number. Square root of a number, A. Now, the square root of number, okay, by definition in mathematics, is going to be the number, okay, some number, okay, whose the positive number, okay, must be positive, because otherwise it's not unique, right? And whose square is 8, okay? That's the definition. When I look at the pre-algebra book, and there's a definition at the very beginning. What's the definition of a -8? Right? If you give an A, what is the definition of -8? Okay, The definition of negative, do you remember, right? The definition number there is a number when it's added to a, it should be equal to 0. Okay, that's the definition. You see, it's pretty abstract, right? Same story here. If you give a, and what is the square root of a? Square root of a is going to be the number whose square is going to be a. So that is number denoted by square root of a. Okay, that is a number, a unique number. When it's a square, it's going to be a. Okay, but that number more likely is going to be irrational number. I want to tell you, more likely. Okay, so and the square of 4 is going to be 2. Okay, it's a rational number. Okay, and the square root of 4 over 9, and that is going to be 2 over 3. It's also a rational number. But square root of 2, square root of 3, square root of 5, square root of 7, all those, even square root of 6. Okay, and the square root of 8. Okay, and the square root of 9 is not, unless it's perfect square. Okay, otherwise they are all irrational numbers. They're all irrational, okay, except for the perfect squares. When you square root of that number, is always irrational, okay, and it's not easy to prove. It's not easy to. So square n is irrational. If a is not a perfect square. Right? It's not easy to prove. Maybe you can try and how to prove square root 2 is an irrational number. Okay, square root 2 is an irrational number. Why is the square root 2 is an irrational number? Okay, you can assume that if it's not, then blah, 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 you get a contradiction. Maybe that is the way you prove. So when you, this kind of mathematical reasoning, you use that in daily life. If you argue with someone, with your sister, with your brother, okay? And then say, if what you say is true, then you get a contradiction, okay? So that means what you said is wrong. That's why, how do we prove it? We call it proved by contradiction. Assuming the assumption is correct, then you get a conclusion, okay? Which is obviously the conclusion. And then you show that the proof and the assumption is wrong, okay? And we do have some basic rules for the square root, like a square root 8, right? And because 8 is 2 times 4, that's why you can separate it. But the square root of 4 is 2, so that's why by the commutative rule, and you can put a 2 in front of the square root of 2. So square root 8 can be expressed as square root 2 times square root 2. Right? Now, how about this one? This is called the nth root of a. Okay, the nth root of a is a number, whose nth power is equal to a. Okay, so that means is a positive number. Of course, we're talking about positive a here. Okay, so is a positive number, a to the n, its nth power is going to be a. It's very similar to the definition of square root a. Okay, in particular, when a equals 2, that is a to the 1/2 has a traditional notation called nth root. But how about in general? In general, we have to put on the left-hand side is a scientific notation, on the right-hand side is a traditional notation called nth root of a. Right. There are certain rules I have to follow, and the mathematicians already showed that. We say if a times a to the alpha times a to the beta is going to be a to the alpha plus beta. Okay. And negative a to the negative alpha is going to be 1 over a to the alpha. Okay. Then a to the alpha times beta. Okay. I'm going to put it here in the denominator, a to the beta. Okay, here alpha beta could be irrational number. Okay, so that is going to be a to the alpha minus beta, and also can be a to the beta minus alpha. Depends on where you want to put it. A. Okay. The last important formula is a to the alpha and to the beta is going to be a to the alpha beta. Okay, let me explain that formula to you. Like a 2 square and a cube means 3 2 squares, right? That's called cube. But each 2 square is going to be 2 times 2 times 2. So total you have a 6. But 6, how to get 6? 2 times 3. Okay? Yeah, so that also can be written as 2 cube and a square, the same. Okay, can switch the order. All right, so now let's take a look at some examples. Oh, wait, by the way, yeah. A times b to the alpha is going to be a to the alpha, b to the alpha, okay? Another one is a over b to the alpha is going to be a to the alpha, b to the alpha, b to the alpha, same alpha. So let me show you example ab squared, right? It's going to be a squared, b squared, y. Why? First of all, ab squared is ab, right? But by commutative rule for multiplication, these two can be switched order. So it's a times a, b times b. That's why just a squared, b squared. Right. This is where a squared, b squared come from. Otherwise, you're not going to get this. Right. All right. So let's take a look at an example. Simplifying this square root of 12, right? Square root of 12 is going to be square root of 3 times 4. And then it's the square of 3, square of 4, but square of 4 is going to be 2. So you can express as 2 times square of 3. All right, so let's do the next problem. This is coming from math cons. 4 to the 11 plus 4 to the 11 plus 4 to the 11 plus 4 to the 11 to the 1 over 4. All right, can you simplify and get the value of this? And if you get, maybe you saw this problem before, if you get it, and post to me privately, okay? Yeah, we don't have a, we have to use when we trying to simplify the expression, make sure we follow those already prove it's true, those algebraic rules, okay? And you don't create algebraic rules, right? So what they do is how many fours there? 4 to the 11th power, okay? Then 4 times 4 to 11 is going to be 4 to the 11 plus 1. Right? It's 4 to the 12. Then according to the above formula, is 4 to the 12 times 1/4. 12 times 1/4 is going to be 3, so it's going to be 3. So this is a 64. Okay? It's going to be 64. Great. All right, so next problem. Simplify 2 to the 2019 and 2021 divided by 2000, divided by 2018. No, sorry, 2020. All right, let's try to simplify this as much as possible. So I like you to try first. Okay. Right, we do get some answers. I got answers from Lala. I think it's correct pronunciation. And we have very good names here. All right, so how do you solve this problem? First of all, you get a common factor, right? 2019, 2 to the 2019. Here's the 2021 is going to be 2019 plus 3, right? So that is going to be 2000, yeah. That's going to be, yeah, 2 cubic, okay? So 19 plus, no, not 2 cubic, square, okay? All right, so that is what we get, right? And then 2020 is going to 2019 times 2 to the 1's power. So you will see that you get a common fact, right? The common fact is 2 to the 2019. And then here 2019, and then there's 2. This cancels out, it's negative 3 over 2. Okay. Yeah, good. Yeah, we have to, yeah, remember we have the definition, right? It says n factorial is going to be 1 times 2 times 3 times 4 all the way to n, right? So by definition, you can stop here, right? So it's going to be, if it's a k, so it'll be k factorial, k plus 1 and 2n, okay? So n factorial is always can be written as k factorial times the remaining of the product of the remaining of the integers. This is using this, you can simplify 9 fact. No, not 9 factorial. We can use a bigger number. Okay. Okay. So I'm going to get 2021 factorial minus 2020 factorial divided by 2021 factorial plus 2020 factorial. Right, each of the numbers is huge, right? Each of the numbers is huge. So what I can do is 2021 factorial is 2020 factorial times 2021 minus 2020 factorial. And similarly, okay, so the common factor is going to be here is 2020 factorial, although this is a huge number. So get 2021 minus 1. And here 2021 plus 1. Okay. Then you simplify it. Okay. Then you get 2020, get 2022. Then you can simplify a little bit. You know, each of them are divisible by 2, right? 2022 divided by 2 is going to be 101, right? And 2020 divided by 2. Maybe you can get further. Let's stop here. This is the simplified number. All right. Now, we have an important identity, 1 over n minus 1 over n plus p. Let's see, can we simplify it? And how do you use this simplified expression? All right, so when you combine them,
you need to have the least common multiple of n.
That's right. List the common non-multiple. Actually, we use the general formula. Just there's no list the common multiple. We can find out just the n times n plus p. Okay. And then you combine them, and then you simplify into the n plus p. Okay, that is interesting. And you can reverse this problem. You know, when you see p over n plus p, and you can separate it, right? You can decompose it into 2 parts, okay? Especially when 1 over, right? Especially when 2 here, n plus 2, right? Okay. What else? Yeah, when p is 1, even more special. And that is a very important formula. Okay. So how do we use it? Let's try to simplify. Right, simplify and starts from 1 times 2 plus 2 times 3 plus 1 over 3 times 4, and keep it going. And 2019 times 2020 plus 2020 times 2021. Okay. So how many terms do we have? 2020 terms. Why I have to use the 2020? Because we just passed 2020. We are now in 2021. Right? So add them together. So I already gave a hint. In order to go further, simplify, you make it more complicated. Okay? And because the first term is going to be 1 over 1 minus 1 over 2. The second term is 1 over 2 minus 1 over 3. The third term, 1 over 3 minus 1 over 4. We keep the parenthesis first, just be cautious. And keep it going. And
there's a pattern.
That's right. Okay, so you expand all of them, and you will see, now you remove the parenthesis. After you remove the parenthesis, all those numbers next to each other gone. So what is left is just only the first term and the last term. And then if we combine them, and it's 2021 minus 1 is 2020, so it's almost equal to 1. Okay? It is almost equal to 1. And when the number is getting bigger, and actually closer to 1. All right. Now, this is a little bit tricky problem, but I want you to try. Okay, 1 over 1 times 3 plus 1 over 3 times 5, 1 over 5 times 7. I'm sorry, yeah. 7, and keep it going. The last term, I believe that's 99 times 111. All right, please go ahead. You get some idea, and yeah, and but be cautious, you know, when you decompose each fraction into 2. Okay. Please work on this. I'm glad here we have a couple of students from my another class. Anyone has answers now? All right, we we get a couple of solutions. All right. We have a two interesting name here. They always post answers quickly. Thank you. We have one called Lala. Okay, another name is called Yo-Yo. Yo-Yo, right? Great. You both get the same answer. I hope you both have answers correct. All right, so here what do we do? You know, if we forgot the formula, that's fine. You're trying to decompose it, right? But when they add them together, you get 3 minus 1. So it's on the top is 1, is 2 here. Okay, we don't have a 2 over there, right? Right, so similarly, 1 over 3 or minus 1 over 5, then you will get 5 minus 3, that's 2, that's on the top. So that's okay. Now we can double this sequence, right? 2, maybe we can also do like that. 2 over 3 times 5, keep it going. 2 over 99 times 1. We can solve that problem first. So that's just 1 over 1 minus 1 over 3 plus 1 over 3 minus 1 over 5, and keep it going. 1 over 99 minus 1 over 1. And all the terms in the middle, they're all gone. So you get 1 over 1 minus 1 over, right? And combine them, you get 1 over 1 minus 1 is 100. Okay, this is almost equal to 1, but you have to divide both sides by 2. The reason I have to divide by 2 is our original problem, there's no 2 in the numerator, right? Okay. So that's going to be 50, 100 divided by 2 is 50. So 50 over 101 is correct answer. And this is a, right. All right. How many of you know how to get this formula? Right? And you do the same. What you do is you double it, but then you turn around, okay? And you double the sum of those two terms. So we can try this way, double. Okay, but when I double it, I can solve in this form, reverse order. Okay. When I reverse order, then I add vertically. I always get n plus 1. I always get n plus 1. Okay, how many n plus 1 there? They're n. Right, so they are n plus 1. But double of that is going to be n times n plus 1. So therefore, the original sum is going to be divided by 2, right? Right, original sum is divided by 2. Right. So 1 plus 2 plus 3 and n plus 1 divided by 2. You don't need to take notes, okay? I always send you the notes. So just focus on what I'm talking about. Okay, now it's time for you to try this problem. 1 over 1, 1 over 1 plus 2, 1 over 1 plus 2 plus 3, 1 over 1 plus 2 plus 3 plus 4, and keep it going. Maybe 1 over 1 plus 2 plus 3, and how many terms do you want? You know, depends. If you want to look at the 100 terms, this end up with 100. Okay. All right. How to figure out this problem? I'll let you to try first. All right. Okay, so let me help you if you're still working on the problem. So the idea is how to express the denominator here. Okay, I already mentioned about formula. So one is just 1 over 1, right? It's okay. Now 1 plus 2, according to the above formula, don't multiply them out. That's the key point. It's 2 times 3 divided by 2. Okay. So and then the third one is n is 3, so 3, n plus 1 is 4. Okay. And the fourth one is 4 times 5 divided by 2. And keep it going. The last one is 100 times 100. We're getting close, right? So then the first one may be 1 times 2 divided by 2. Okay, so now what do you get? Well, you get 2 on each term on the top of this term. So it's 2, 1 times 2, right? I'm sorry. Yeah, my setting for my pen is not good. This is a setting for the drawing. Yeah, it's 2 over 1 times 2. 2 over 2 times 3. 2 over 3 times 4. 2 over 4 times 5. Now you're getting close, all right? Okay, then use the above formula we learned. Okay, so let's see. This is 1 over 1 minus 1 over 2. 1 over 2 minus 1 over 3. And keep it going. And 1 over 100 minus 101, right? And all the terms in the middle still cancel out. And the 1, right? 1 minus 1 over 101, that's 100 divided 101. And then this time is not divided by 2, it's multiplied by 2. So this is our answer. Okay. We know that when x squared minus 1 is going to be x squared minus 1 squared is x minus 1, x plus 1, right? Similarly, 1 minus x squared is 1 squared minus x squared. It's 1 minus x, 1 plus x. Okay. With this in mind, and we want to simplify, okay, 1 minus 1 over 9, 1 minus 1 over 16. And this should be a perfect square. Let's try 2,500. 2,500 is a perfect square. So the denominator here, those are perfect squares. Okay, 4, 2 square, 3 square, 16 square, you know, so on. And here we all do the multiplication, right? And how do we solve this problem? Let's take a look at what do we inside here. 1 minus k squared, right? 1 over k squared is going to be k squared minus 1. Then so what? Well, I can factor the numerator, and I can k squared times k, right? Something like that. All right, so using this, what I'm going to do is here, the first one is 2 squared. That's 2 squared. K is 2, right? So 2 minus 1, 2 plus 1. Again, don't multiply them out. The second one is 3 squared. And that'll be 3 minus 1 and 3 plus 1. And the third one is 4 squared. 4 minus 1 and 4 plus 1. Okay, and so on. The last one, I think the last one is what square? 50 square, right? Yeah. So 50 minus 1 and 50 plus 1. Then so what? Then what? Well, we can regroup them, okay? Denominator is 2 square, 3 square, 4 square, and 50 square, okay? The numerator, I record the first term, first fact first. So it's going to be 2 minus 1, 3 minus 1, and 50 minus 1, okay? Then 2 plus 1, 3 plus 1, and 50 plus 1. Yeah, regroup them, okay? There's so many, because those are 2 minus 2, 3 minus 1 are similar to each other, okay? Then what? I think we're almost there. This is 1 times 2 times 3 all the way to 49. And here's 3 times 4 all the way to 51. All right, can we simplify? Answer is yes. How? Well, you see that, right? We get squares, you know. From 3 to 49, they're all squares. 3 to 49, they're all squares. Right? So we have 1 times 2, 3 square, 4 square, 49 square, 50, and 51. Right. Right. So all of them in the middle, they're gone. So what is left is 1 times 2 times 50 times 51, 2 square and 50 square. Okay, then you Carefully get rid of this. Carefully get rid of this. And the 51 over 100. 50 over 100. That is the answer. Right, that is pretty challenging, right? But if we just go ahead, you can work out. Finally, I want to talk about one type of problems, which is giant fractions. We have to simplify it. Okay, so simplify 1 over 1 plus 1 over, let's say just 1 over, okay? 1 over, 1 over, 1 over, and I think this, let's stop here. Simplify this expression, okay? And I'll give you 1 minute, okay? Right, you get you'll get 5. Someone gets 5 over 8. Someone gets 2 over 7. I will get 3 different answers now. Okay, I get 3 different answers. Okay, sounds like you need to be more careful when you do the calculation. All right, let's stop here. I'm going to show you, okay, step by step. You can always add, right? And this is a 1 over 2. So, right? And this will be, that'll be 3 over 2, so it's 2 over 3. And 1 plus 2 over 3, right? It's going to be 5 over 3, right? So that'll be 3 over 5 then. Okay, this will be 8 over 5. That will be 5 over 8. Wow. Is there any shortcut? No, there's no shortcut. However, this problem, if I have a forever, okay, and what is that number? And this problem actually is much easier than the previous problem. Okay, how do you do that? So let's stop here, right? So I'm going to call it x. Well, if you let x to be this number, okay? So this is a limit concept, you have forever, you have infinitely many ways to do the problem, right? To write down this expression, going deep, but never stop, okay? But this number is also does not increase so fast. So what I see is this x and that part is the same. Okay, so that means x over 1 over x, okay? But that is also x. Okay, so then you can figure out what is x. So x times 1 plus x is 1, x squared plus x minus 1 equals 0. Okay, then you solve for x, right? Then you solve for x. Then what do you get? X is going to be negative b plus or minus b squared minus 4ac. 4ac. Okay, so it's going to be, okay. So our x is positive. So you have to choose the positive sign. Okay. So you will be surprised. This number is going to be 1 plus square root of 5 divided by 2. And the 1 plus square root of 5 divided by 2. The question is why this is an irrational number, right? And I just showed to you. Okay. So this number, if you can write down infinite line in the infinite terms here, right? So right, you know why I get this equation like x equals 1 over plus x. We're not going to talk about limits here, but this is a kind of, you need some kind of limit concept, okay, to understand this problem. All right, I'm going to stop here. You will get similar problems. Most of you can finish it quickly. Right? And if you want to stay in this class, you're welcome. Okay? But you don't need to hang on the other easier class, right? Intermediate math class. You should give up that one. Bye-bye.